A very good morning, good evening, sorry. A very good evening to all of you. And today we are here with Assertion and Reason series for 1 mark solution for class 12th. And today we are going to discuss the chapter Amines. The chapter details are here and the video link is here. I am Manisha Sharma from Martyr School. First assertion statement that we have in front of us is Hoffman's ammonolysis can be used to prepare pure primary amines. Now, Hoffman's ammonolysis is a process. If you know the reaction, it's Hoffman's bromamide degradation reaction. So basically, we start with an amide. And what happens to this amide is that it undergoes certain degradation and gives you an amine. That's absolutely correct. And we get a primary amine. But are we getting a pure one or ammonolysis is giving? Now, ammonolysis, the process is, you have NH3, you react it with RX, and you somewhere get RNH2. Then you further react with another RX, so you get RNHR. So ammonolysis is the process of using ammonia, and here it says that it can prepare pure primary amines, which is not true. So assertion here is true. Assertion here is false, and reason says ammonolysis of haloalkanes lead to multiple substitution of alkyl groups on nitrogen, which is true because if you see the reaction that I have shown you here, you have got NH3, then you are getting a primary amine, then you are getting a secondary amine. If you're going to react it with RX further, you are going to get a tertiary amine. So you are going to get a lot of alkyl groups on the substitution. So reason is true, but assertion is false because it is not going to give you a pure primary amines, but a mixture of primary, secondary, and tertiary. Second assertion statement that I have is aniline is less basic than ammonia. That's absolutely correct. And the reason for that is very simple. Aniline, if you see, has a benzene ring and NH2 is associated to this. The lone pair of nitrogen is already there. On the other side, ammonia also has a lone pair of electrons, but in aniline, the lone pair of electrons undergo conjugation with the benzene ring and undergo delocalization, because of which they become less basic. And the reason that they say is the lone pair of nitrogen in aniline is donated into the ring through resonance. That's what I said, conjugation. So assertion is true, reason is true, and reason is very well explaining the assertion. So we go by the option A. Third statement that we have is tertiary amines have lower boiling points than corresponding secondary and primary amines. This is also true because if I can show you, this is tertiary, this is secondary, and this is primary. So when you have this, I have already told you this is a branch 1, 2, 3, 1 and 2. So the branching is maximum in tertiary, because of which the surface area is very small. And if you start heating it from, one point, suppose from nitrogen only you start heating it, so the heat will go here very fast, right? But if you start heating it, will take 1, 2, and it will take certain time because the surface area is now increasing. So assertion here is definitely true. Now the reason says tertiary amines have higher intermolecular hydrogen bonding. No, it doesn't have any hydrogen basically. So it's very, very bulky. It has got 3 alkyl groups attached to it. So reason is false, but assertion is true. Fourth statement that we have is tertiary amines do not undergo acylation reaction. What does that mean? Acylation reaction is a reaction where you are forming compounds with RCOCl. So since you do not have an active hydrogen with tertiary amines, normally what happens, if you just imagine this to be H, what happens? This is secondary. This H will go off with the Cl as HCl. But when you have tertiary, you do not have any active hydrogen. Since you do not have any active hydrogen, that HCl will not go off. If the HCl is not going to go off, the acylation reaction will not happen. Now, the reason is there are no irreplaceable hydrogens on the nitrogen in tertiary amines, which is absolutely true. So assertion is also true, reason is also true, and reason is explaining assertion well. Fifth statement that we have is carbylamine reaction cannot be used as a test to distinguish between aniline and methanamine. Carbylamine reaction undergoes the formation of isocyanides. That is why this is also known as isocyanide reaction. So in aniline and methenamine, formation of isocyanide is not that feasible, and because of it, the carbylamine reaction cannot be used. Now, reason, it says that both aniline and methenamine are primary amines, which is absolutely true. So assertion is also true, reason is also true, and reason is explaining assertion. That's why isocyanide formation cannot happen, because it's primary amines. Next statement that we have is diazotization of aniline should be done near 0 degrees Celsius. Now, diazotization reaction, if you remember, we read it in haloalkanes also, Sadmeyer's reaction, 0 to 5 degrees Celsius. So even, near 0 degrees Celsius means 0 to 5 degrees Celsius. So we can assume that assertion is true. And reason says aniline is less reactive towards sodium nitrite at normal temperature. This is not true. Why is it not true? Because this temperature that you are maintaining, 0 to 5 degrees Celsius, it is important to be maintained so that the reaction can happen feasibly. Less reactivity or more reactivity is not the concern, but it is more about the activation energy that the compound is going to get. So assertion is true, but reason is false. Seventh statement that we have is aniline forms significant amount of meta-derivative or nitration with concentrated HNO3 and concentrated sulfuric acid. This is very much true because aniline, when reacts, basically NH2 is orthopara directing. But when you react it or make it undergo nitration, you get some amount of, meta-directing product as well. So assertion here is true. Now, reason says the ortho and para position in aniline is electron rich due to the activating nature of NH2. That is also true because ortho and para position is, directed by aniline. Aniline has NH2, which is ortho para directing. So, of course, ortho and para position has electron density, because of which it is ortho para directing. So, assertion is true. Reason is also true, but reason is not explaining the assertion. Why? Because reason only talks about ortho and para position and is not talking about the meta position. Eighth statement that we have is aniline does not undergo Friedel-Crafts reaction. Absolutely true. And that's because Friedel-Crafts reaction involves catalyst, which is anhydrous aluminium chloride. Now, aniline has NH2 group in it, and this NH2 group forms a salt with AlCl3, because of which reaction doesn't happen. Now, reason says being a Lewis base, aniline reacts with anhydrous AlCl3 to form salt, which is true. So we say assertion is true, reason is true, and reason is the correct explanation of assertion as well. Ninth statement is aniline cannot be prepared by Gabriel thalamide synthesis. This is true because Gabriel thalamide synthesis can only prepare compounds like RNH2, that is aliphatic primary amines, and aniline is aromatic, so it cannot be prepared. Reason is thalamide does not react with chlorobenzene due to large size of phenyl group. This is not right. So assertion is true, but reason is false. 10th statement that we have is acetylation of aniline enhances the tendency to undergo electrophilic substitution. This is absolutely false. Acetylation is a reaction where we are, reacting AR. I'm using AR for aniline, and you are supposed to react it with RCOCl. So it says that if you are going to acetylate this aniline, it is going to enhance and undergo electrophilic substitution. So it doesn't happen because it is supposed to be done in the presence of anhydrous aluminium chloride, and anhydrous aluminium chloride forms the salt. That is why neither Friedel-Crafts reaction, alkylation, and Friedel-Crafts acylation, none of these reactions happen. So assertion is false, but reason is true. Acetylation reduces the activation basically, and this NH2 group is then bonding with benzene ring and acetyl group, and undergoes resonance, because of which the electrophilic substitution tendency is not enhanced. So that's all from my side. All the videos are lined up here. These are the channel details. Please do like, follow, and subscribe. And for more videos, you can look at the channel. Thank you so much. Have a good evening.